Hello, my name is Pashala Soy. Today I will present my project name is EEG-Based Prediction Model for Drowsy Driving Detection with my teammate's name is Ashiraya Sitharot. So let's start from the first one is our overview. We have introduction, objective material, system overview, theory, methodology, result and analyze, conclusion and reference. So I will start from the first one is our introduction. Our introduction have separate into three parts. The first one is problems, second is solution, and the last one is what we got from this project. In the first one is key problems. There is no reliable system that can detect drowsiness as happens. And also the symptoms are often subtle. You can notice them in time. EEG data which tell us what's going on in the brain is very complex. Plus, most systems don't predict future state and the way that they show data isn't user-friendly. And how we solve all of this problem. The first one is pre-process EEG data for analysis. Second is classify alertness using XGBoost and forecast EEG trend with Pompet. Also visualize result with gear labels and support real-time drowsiness detection. And what we got from this project? We got the real time to prevent accident and a strong foundation for wearable tech that monitors your brain. A new tool for doctor and researcher and also process in state AI through non-invasive EEG monitoring. So now let's talk about our objective. In the objective, it have 4 key goals. The first one is classify, that's mean detecting whether someone is alert or drowsy by analyze EEG signal using machine learning, and we use model like XGBoost for that. Second is we aim to forecast EEG signal trends, not just analyze current that in the state, but actually predict what is coming next using time series modeling. This helps us to detect drowsiness before it's become dangerous. And third, we want to develop a system that can monitor that the user in real time. And not just any system, but one that non-invasive, easy to use, and ready to practical application like driving safety or healthcare. And finally, we want to visualize all of this, turning complex EEG data to clear and useful graph that anyone can understand, whether it's for research, safety, or daily user. These 4 steps, classify, forecast, develop, and visualize, are the foundation of our group. And the materials in this project, the first one is dataset. We work with EEG recording that include various brainwave features like delta, theta, high gamma, high beta, and high alpha. Each record is labeled to show whether the person was alert or drowsy, which is the key target of our group. Second, the development tool. We handled data in CSV format and process it for both machine learning and time series forecasting. And third, the software and libraries. We use Python along with key libraries like pandas and NumPy for data handling, XGBoost for classification, Prompt for forecast, and Matplotlib for visualize. And the last one is Skitlearn to help us splitting data and evaluating accuracy together. And these two form is the backup of our system. And this is our system overview in step by step. So the first step is data acquisition and processing. So we begin by import EEG data and converting time into second. Then we prepare the EEG feature so they are ready for both classification and forecasting. Step number 2, we classification with XGBoost. We use XGBoost to train machine learning model. Its job to predict whether the user is alert or drowsy based on their brainwave patterns. This model gave us high accuracy, which we all know. We will show you later. Step number 3 is time series forecasting with prompt. We don't just stop detect the current state. We forecast what's coming next. Using prompt, we predict how each EEG feature will change over next 120 seconds. We also calculate confidence intervals to see how reliable the forecasts are. And step number 4, visualize. We plot the prediction on graph alongside the actual classified state. This helps us clearly see when drowsiness starts to appear before it's physically noticeable. We highlight this moment to make interpretation easier. And the last step is application potential. Ultimately, our system can be applied in real time to help detect drowsiness, whether in transportation, healthcare, or even day-to-day monitoring.
Let me talk about theory. To start, EEG or electroencephalogram measure brain activity through different frequency bands. Delta tell deep sleep, theta tell awareness and drowsiness, alpha, beta, gamma tell alertness and focus. And why we should puppet and XGBoost because XGBoost is fast and accurate for classification, and puppet is flexible and reliable for time series prediction. And methodology, we have four stages. Stage one is data preparation for cleaning and structuring EEG signal. Stage two is XG-boot modeling for training and classifier to predict alert versus drowsy state. Stage four, stage three for forecasting prompt for predict over 120 seconds. And visualization is last stage for combined classification, result, and forecasting comprehensive graph. Let's start for stage 1, data preparation. First, we load the EEG dataset from CSV file and we check and convert the time column into the date time format and drop any missing value to ensure data quality. Then we transform the time into the second and create the timestamp column called DS as required by Puppet. After cleaning, we select EEG feature. Finally, we split the dataset into 80% and 10 80% for training and 20% for testing. And next stage is XGBoost modeling. We use XGBoost to classify the diverse state, and we should higher parameter include a 100 estimator and learning rate of zero point 0.1 and maximum depth of 7. After training on the selected feature, we evaluate the model using the testing set. The model achieved an accuracy of approximate 82.35%, demonstrates strong classification performance. And the next stage for forecasting To forecast future EEG trend, we use the Puppet model, separate Puppet model for each of EEG feature, allowing the model to predict 120 seconds into the future Puppet output, and we got the Puppet output include the predict value y-hat and predict interval y-hat lower and y-hat upper with the help echo EEG signal. And the last part is visualization. We plot the forecast EEG signal trend as a color line with the shade area represent the confidence interval. Also, we scatter point showing the actual diverse state. Red point for alert, orange point for drowsy based on the data signal. And in the graph we show accuracy by XGBoost, and this is the result analysis. We present the forecast result for multiple EEG feature combined with the classification output. Each graph will show how the signals specify brain wave change over time. First graph is delta, high alpha, theta, low alpha, and next slide for the show data from low beta, low gamma, high beta, and high gamma. And this is the result when we use the XGBoost model. First up, data was split into 80% training and 20% testing, achieve accuracy approximate equal 82.35%. And the second graph from the Puppet model, successful forecast trade for all EEG feature for next 126. Y hat it predict value from the Puppet model. The Y hat lower and Y hat power of the prediction interval show the range in which actual value. The final visualization we observe that the forecast generated by Puppet closely follow the actual EEG signal pattern. The separate between alert and drowsy state was clearly visible toward the second point, and the red dot for represent the alert state and orange dot for represent the down state. And why we should plot the delta wave value, because delta wave show the strongest correlation with deep sleep and drowsiness, making the effective for between the two states.
And this is the data that we forecast result for multiple EEG feature combined with classification output. Each graph shows how the signal of specific brainwave change over time. As you can see in the presentation, we have delta, high alpha, theta, low alpha, low beta, low gamma, high beta, and high gamma. And this is the conclusion of our group. In this project, we combine machine learning with time series prediction to make sense of EEG brainwave data. We use XGBoost to help the system tell if someone alert or starting to feel drowsy, and it works with high accuracy. We also use prompt to predict how the brain signal will change over time, so we can catch the sign of drowsiness before it happens. The graph we create make it easy to see what's going on inside the brain in real time. Overall, this system is a strong first step toward building real-time tools that can help to prevent accidents, support healthcare, and better understand how our mind behave. And this is our reference. And the signal could be the second that saves a life. Thank you.